Okay, so we're starting off with the titration, the acid-base titration lab. What I'm trying to show you here is where the beginning of the meniscus is, and I read that at about 0.1 as our initial spot, and hopefully you can see that. So I'm going to remove that, and what we have is we've made the solution of sodium hydroxide, and hopefully you can do the calculation to figure out how many grams of sodium hydroxide you need to put into 300 milliliters to make the solution. Now it says to be about 0.1 molar sodium hydroxide, but the problem with sodium hydroxide is that it's hygroscopic. And because it's hygroscopic, it sucks water out of the air, and so we never really know with any sort of certainty how much sodium hydroxide there is in the solid. So what we have to do here is we have to test the solution against a known compound, and that's going to be sodium hydrogen phthalate and potassium hydrogen phthalate, excuse me, KHP, and it is what we're going to use because it has a known amount of hydrogens in it. And so what I have done is I have put in the requisite amount to determine the concentration of this solution. And so I'm going to add the sodium hydroxide until it turns the solution of KHP pink. And when it turns it pink, then I'll know that I have reached the equivalence point and that the number of moles of base that I've added is equal to the number of moles of acid inside the flask. And at that point, I should be able to calculate the number of moles of the base that are in the solution that I've added. And from that, I can determine the concentration of my sodium hydroxide solution. And then once I have that information, I can use this solution of sodium hydroxide to tell me about some other things that I don't know. And so that's the whole genesis of this lab, is to make a solution, figure out its concentration, and then use it to identify information about other acids that we don't know anything about. So a known sodium hydroxide solution will allow us to determine things of an unknown acid that we're working on. Okay, so here is our solution with the requisite amount of potassium hydrogen phthalate. Hopefully you've calculated how many grams I would need to put in here to react with the required amount of sodium hydroxide. And so to this solution, I've dissolved all of the potassium hydrogen phthalate into water, about 50 milliliters. I'm going to add 2 drops of phenolphthalein. And that's going to help tell me when the reaction is done. Okay, so I started off at 0.1 for my volume of the sodium hydroxide. So we're going to go ahead and open up the stopcock on this burette, and we're going to add it to this beaker here. I have you see my hand. So you can look, and hopefully you should start seeing colors form here. Can you see the slight pinkish tinge? And that's a good thing. That means things are happening here. So I'm going to slow this down a little bit, and you can still see a little bit of pink, but it's gone away. So I'm going to add a little bit more, a little bit slower this time. Okay, I'm going to look for that pink coloring. And when the pink color persists, then I know I need to stop and make sure that I have exhausted all of the acid in the form of potassium hydrogen phthalate as I do this. So I'm going to let it sit and see if we can get it to go back to pink. Looking, and it's some pink, still pink. Adding. Okay, we're going to slow that down, swirl it a little bit more. It looks like it's persisting. Just the palest of pink, but that's what we're looking for when we do this titration. Now we're going to let this sit for about 30 seconds and to see if everything stays there at that very, very pale pink. Move it here so you can have a look at it, how pink that is. It's not very pink at all, but it is just a little bit. So I'm going to, yes, that is the color that we're looking for. It's just the faintest whisper of pink here. And that would tell me that we are reaching the equivalence point. All right, so we're going to go ahead and record what the value is here then of this burette. And we'll get it to a point where maybe you can see it. Let me back it up a little bit where we get the focus. Looks like we are at 27, and I don't know if you can read the meniscus as well as I can, so I'm going to try and, yeah, it doesn't focus as well as I would like it to. But I could tell you that it is at 27 and halfway between the 1 and the 2. So I would say 27.15 milliliters are what I dispensed to get that. Now, just to give you a sense of what's going on here, I'm going to add just a little bit more of this. And you should be able to see how it will enhance that pink color. So hopefully it's just a slight bit pinker. And then if I just do one more drop, I'll give it a good jolt. And there, you should be able to see a lasting pink color. Okay, so that's the first one. We went from a 0.1 to 27.15 milliliters for that first one. And we're going to set up for a second one. Okay, this is me holding it up so you can see it. The burette is at exactly on the 0 mark. So we're just going to go based off of that. And we have our second solution of the potassium hydrogen phthalate. And we are going to titrate it again. So I need to add my phenolphthalein to my solution. And then we'll be ready to titrate to figure out how much we need. So go ahead and get our burette into position here. And we will add it to our potassium hydrogen phthalate. And we'll go ahead and see if we can get this going. So we'll go ahead and open that up. Now I have a good sense for where this should end up. So I can probably go pretty fast to about 20 milliliters and then start slowing down when I get there. So we're close to 20 milliliters, so I'm going to now slow it down a little bit. You can see that there's that pink color. As I swirl it, it disappears, so we're still not at the equivalence point. Okay, so we're adding. We're doing well, and we just want to watch it until we get to that spot where we see the pink persist, and then we know that we have reached the equivalence point, and we can make our calculations based off of that. So, not quite there. We should be really close. We're about 26 milliliters dispensed here. So we should be getting really close to that equivalence point. I'm going to stop it here. Give it a swirl. Still could use a little bit more. Still not quite. Well, maybe. Nope, not quite. There it is. We hit it. Okay. So we found that spot. Let's come up here and look. And I'm going to take you with me here. There's our lovely pink. It's staying there pretty good. So we come up here and we are at, oops, too close. A little less than 27, so more than 27, I should say. So it's not focusing for me. It's 27 point, if I'm guesstimating that, 0.7. 27.7 is what I would say that was. And so that's what we would record for our second titration, 27.7. So we started at 0, so we dispensed exactly 27.7 milliliters of our sodium hydroxide. So we now should be able to calculate the amount of sodium hydroxide there is based on these two samples. And they were both supposed to be the same mass. So whatever you calculated out for the mass of the potassium hydrogen phthalate, I measured that out the same for both and put them inside of the beaker. So they should have had the same amount of KHP. And so they had different volumes added of the sodium hydroxide. But we'd go ahead and calculate the concentration of the sodium hydroxide by determining the number of moles of sodium hydroxide, which should be equal to the number of moles of potassium hydrogen phthalate, and then dividing it by the volume. So for the first one, it would be 27.05 milliliters, and for the second one, it would be 27.7 milliliters. And then we take that concentration and average it, and that would be our concentration of sodium hydroxide moving forward. Okay, so now that we have calculated the concentration of our sodium hydroxide, we're going to want to identify some unknown acids. So I'm going to go prepare those solutions now. Okay, now that we have had a chance to go and measure out an acid, so we have an unknown acid here, and we were instructed in our lab to measure out between 0.2 and 0.4 grams. And so in this one, I have put my 0.2 grams of an unknown acid. This is a monoprotic acid, which means it has one hydrogen. So we're going to go ahead and record the titration of this. So to this, I need to add my phenolphthalein. So I put in 0.2 grams of an unknown acid, and I'm using my sodium hydroxide solution. Now this one, I would show it to you, but I'm afraid that my shaky hand would not do it justice. So we are right on 0 milliliters on our burette. So our initial reading on the burette should be 0. So let's go ahead and start titrating this sample. So I'm going to go ahead and open up my burette and let it run. I do not know how much I need to add, so if it starts turning pink on me, I'm going to slow down. Okay, I haven't overshot the endpoint yet, so that's good. Okay, so kind of pink, so we'll swirl it around. Sorry for the hand there. Turn it back on. Slow and steady. Looks like we might be there. Yep, looks like it's staying. So let's watch it for just a little bit. Make sure that it doesn't turn back to the clear. It's just the palest of pinks. I hope you can see that. And for this, looking at the burette, looks like we are 21 and I'd say 0.04. 21.04 would be my guess. Just below the 21, but not quite to the 0.1. So 21.04 is my guesstimate for what that is. Definitely 21 and a little bit more than 21. So 21.04 would be the final reading. So we have dispensed 21.04 milliliters into this sample, and you can see that lovely pink color there. Okay, so let's do a second sample, and I think we've used a little enough of this that we can use the same burette. So we're going to start off with 21.04, and we have our solution here. So we're going to go ahead and dispense ourselves. So this is the same 0.2 grams of the unknown monoprotic acid. So we're going to go ahead and add this. So again, our initial reading was 21.04. We're going to add this to our solution. We did not add the phenolphthalein. It's okay, we aren't to the point yet. So we should just go ahead and add our 2 drops, just to show you that sometimes lab gets crazy and you forget. There we go, we have our phenolphthalein. We would be here a long time if we didn't add the phenolphthalein. Never turn pink, we'd never see that happen. Okay, so we have our solution here. Adding, not quite seeing the pinks staying constant there. Okay. Still not staying pink, so let's go ahead and add a little bit more. Getting close. Okay, so it looks like we have reached that point. All right, we have reached pink there, and looking at this, we are now at 42.5 on the money. 42.5 is the amount that we've dispensed. So we have now gotten 2 readings on this. Should have been the same 0.2 grams, and we did 21.04 for the first one, and now we have 42.5 minus 21.04, so that's going to be 21.45 milliliters were dispensed to turn that at the equivalence point. So we should be able to determine the number of moles of acid that were in here, and we can use the number of moles and the grams, which was 0.2 grams. So if we take the grams divided by the moles, that should give us a formula weight for this acid. All right, well, there we go. Now we have a little bit of a bonus round for those of you who are a little bit more enthusiastic about calculating things. And we will set that up and bring it right back. Okay, for those of you who like to do a little bit more daring calculation, we're going to use a diprotic acid. So it has 2 equivalents of hydrogen for every 1 acid molecule. So we're going to go ahead and put this unknown diprotic acid here. And we're going to add our phenolphthalein. And we're going to use a burette that is starting at 0.01 milliliters of our sodium hydroxide solution, and we're going to go ahead and titrate it to find the endpoint. So here we go. So the amount of acid that we added to this was the same 0.2 grams, but it's a different acid. So it's probably going to take a different amount of our solution, of our sodium hydroxide solution. Staying pretty pink. Getting close. Down just a little bit. Not quite there, but we're getting it. Slow drops. See what happens with the slow drops. I'm sure you've figured out this by watching me, but the closer you get to the endpoint, the slower you want to go, because if you're going fast, you may just zip right past it. Oh, looks like we're there. Okay, so let that sit for 30 seconds and see if we found it. Looks like, yeah, it's still that nice pale pink we're looking at. A little bit closer so you can see the difference. Nice pale pink. And we have dispensed 35.6, I want to say 1 on that. So 35.61 milliliters, starting at 0.1. So we take the difference between those, so that's going to be 35.51 milliliters to change this from clear to pink. Okay, what we're going to do is we're going to fill up our burette, and you don't need to listen to that, so I'm going to fill up our burette. All right, so we have filled up our burette, and we hit the 0 mark exactly on this one, so feeling pretty good about life. So let's go ahead and add our phenolphthalein to make sure that we can see the transition of our second sample of the diprotic acid. So we used 33.51 last time, starting at 0, so we should be somewhere in the neighborhood of 35. So let's go ahead and just open the floodgates here and get to about 30, see what happens. A nice pink there. It's going away pretty good. Okay, we're getting to 30, so we're going to start slowing it down. Slower now. Looks like the pink color is going away after the drops. And just to remind you that this was 0.2 grams of the diprotic acid, and we're using our solution that we had generated of the sodium hydroxide, so that should allow us to determine the number of moles of hydroxide in the solution after we add it to this unknown acid. No, not quite. So stop there and see if it's persistent. It is persisting. Okay, we have reached it. Okay, so we started off at 0, and here we are at 35.5. Wow. Okay, well, there we go. 35.5 milliliters was our endpoint. We started at 0, so 35.5. So this is the diprotic acid, and so we can figure out that the number of moles of acid is equal to the number of moles of base, but because this molecule has 2 hydrogen atoms, the number of acid molecules are going to be less, because for every 1 acid molecule, you're going to get 2 H pluses. So we should be able to figure out the formula weight of this one. So remember, we used 0.2 grams on this one as well, and we have used 35.5 and 35.51 milliliters of this sodium hydroxide that we have constructed, and we put it all together. Okay, fantastic. So whether you're doing the monoprotic or the diprotic, you do those calculations for that. We have one more portion to this lab. So the last section of this lab is to use household vinegar. And we have a bottle of household vinegar here, and we have pipetted exactly 5 milliliters using one of these lovely volumetric beer pipettes, and I placed that inside of our Erlenmeyer flask, and then I've diluted it to 50 milliliters of water. And so we're going to go ahead and titrate that to figure out how much acetic acid there is in the vinegar. So this is a weak acid, but that shouldn't matter to us because the number of moles of acid should be the same. So I put the phenolphthalein in, and the starting part of this burette, we're at 0.1, which is a common theme so far. So here we go. We're going to add our base to our acetic acid solution, and the initial amount of acetic acid was 5 milliliters. And we're going to go ahead and see if we can calculate how much acetic acid there is in that initial 5 milliliters. So even though we've diluted it to 50 milliliters, there's still just the acid in that initial 5 milliliters. So our calculations are going to be based on that initial 5 milliliters. All right, so here we go. Adding the base. Slow it down a little bit because that pink color is persisting. Just a little bit. Pink glow from outside, it looks like. We're still. I missed. Uh-oh. That's going to cause trouble, probably. Left it off the thing. So this one's going to be not as exact as the other one. Oh well, such is life. Get for looking at the camera instead of paying attention to the titration. Neato. That paper out the way. Wipe up the mess. There we go. Still going. See if that's persistent. Not quite. We're getting real close to the end here of our burette, not necessarily the titration. I hope the end of the titration because we don't want to go past the graduations on the, oh, there we go. Okay, so for this one, it took 48.9 milliliters. This one's got a star next to it because we dribbled a little bit off the side there. We don't know how much, so it's hard to say. So we're going to take this one because it's going to help us be in the neighborhood, but it's not going to be as exact as it could be. Let's move on to the next one. Okay, so we have that exact same thing going on, and we're going to switch burette. This another burette that we're going to use is exactly at 0. So we'll go ahead and move that over so that we can be in the location. Swirl it up. We're back to being clear, and we're just going to go probably head to 40-ish based on that last one. So we're going to go ahead and add our burette. Now we are using, again, 5 milliliters of acetic acid that's been diluted to 50 milliliters with water, and then we're adding our sodium hydroxide solution that we made at the beginning and waiting for it to turn pink so we know exactly how much acetic acid is in the vinegar. We're doing well. Still, the pink color is going away when we swirl it. Okay, we're getting close to 40, so we'll go ahead and slow that down now. Okay. Maybe speed it up just a little bit. Waiting for that pink color to persist. Feel like it's a tongue twister. The Peter Piper picked a peck of pickled peppers, or the pink persisting. At least it's not the sixth sheep is sick. We're getting close to the end of our burette again. So we are around 46 milliliters, but we're still waiting for that. Slow down this titch. No, not quite. Getting there. Up a little more. There we go. Let's see if we're there. We are. Okay, so we are just below 48. So 48.15, I would say. So 48.15 milliliters it took to change this to the pink. So we didn't lose much when we dribbled it over the side there, would be my guess. But we're going to use those numbers to help us figure out the number of moles of base using the concentration. And then we're going to use the number of moles of base to figure out the number of moles of acid. And we're going to use the number of moles of acid to figure out the number of grams of acid. And acetic acid is a monoprotic acid, so the moles should be equal to that. And so you'll figure out the grams of acetic acid, and then you should be able to figure out the mass percent of vinegar based on the mass of your initial 5 milliliters. And I think on that one, we should definitely assume the density of water, which hopefully everyone knows is 1 gram per milliliter. Okay, so that's all the doing part of the titration lab. So hopefully you can answer the questions at the end of that lab and be able to figure that all out. Happy calculating, everyone.